I'm going to do another 5 practice problems, but this time with quadratics. So you can get quick and good at graphing those, doing them quickly and easily. The supporting videos that will support some of the things I'm talking about in a few minutes. Quadratics in the graphing form, speed graphing, ax squared plus bx plus c. Quadratics finding roots if given the a and then right value, but given the a value and the vertex. And a geometric look at completing the square. Those are all things that I would welcome you to look at. And again, repetition is everything in math. And so I'm going to do 5 user-friendly graphs here. Coefficients, easy to work with. Minus b over 2a is the average of the roots of a quadratic. It's also going to become the x value of the vertex, so we can find it really quickly and easily. And f of minus b over 2a will get you the y value. Once you have the vertex, you can put it in graphing form, ax minus h squared plus k. And a little known fact, the a term of a quadratic is rise over run squared as measured from the vertex. We can check the a term so that you get a little handle of that. I think that allows you to put any quadratic, if you got a vertex and a random value, into graphing form quickly. And what else do I want? The b value is actually the rate of change at the y-intercept. So ax squared plus bx plus c. B tells you how you're changing at the y-intercept, and some of those supporting videos explain that. When a is greater than 0, we've got a cup shape up. When a is less than 0, we got a cup shape down. And the roots can be found by very quickly working with the vertex and the a term, h plus or minus square root of minus k over a. I think I did an intellectual exercise with quadratics that go after that. I should have put that in with the supporting videos. All right, so I'm going to erase this because I got the values over here that we're going to work with. Got to find my eraser. Have it. And let's have at it. Right? I don't know how much of this. I'll just erase this. Right? And then just work with our first quadratic. Y equals 2x squared plus 20x minus 5. So I know 20x minus 5 is the tangent to the y-intercept. So there's the line 20x minus 5. I also know it's cup shape up. So I've got something that looks like that, which means the x value of the vertex, the y value of the point of inflection right now we are given. So that's 0, negative 5. And we're going up at 20 to 1. All right. So this has got to be negative. My x value here has to be negative. Let's find it quickly. Minus b over 2 times a. So it's negative 5. There we go. So that's negative 5. And if I put negative 5 in, that's minus 100. This has to be positive 50, or I've made a mistake. Negative 5 squared, 25 times 2 is that. And so it's negative 55. Let's do a quick rise over run squared. The rise, negative 55 to that is 50 units. And the squared change from negative 5 to 0, squared change is 25. And 50 divided by 25 gets us the a term. Now, what are the roots? I said you can find the roots really easily. They're real, right? The roots are intersecting at a height of y equals 0. And we can measure from negative 5, our x values, plus n minus the square root of the distance from negative 55 to 0. I got to go up 55 units. So it's the opposite of k. I never put it into graphing form. Let's do that now. Plus 5 minus 55. Okay, if I set that to 0, you can see why I have to go up 55 units. And I'm dividing by 2 and taking the square root. And there are the roots. And the explanation for that is in the supporting videos. Okay, so now let's do another one. Let's get 5 practices in. Mechanics usually precede understanding concept. So y equals, the next one I'm going to do is 3x squared minus 12x plus 7. Okay, so I know it's cup shape up. I know I'm on the decreasing side for my y-intercept, 0, 7. And I'm actually going down at 12 to 1 right there. I'll just put it there. So I now again have an x value, in this case is positive, minus b 12 over 2 times 3 times 2. Did I do that backwards? Minus b over 2a, I just did cubics a minute ago, so 2 times 3, okay, keep it in the proper order. So an x value of 2, I've got to put 2 in, so there's minus 24, this is better be 12. 2 squared 4 times 3, no mistakes. And so minus 12 plus 7 is minus 5. Again, what's the range here from negative 5 to 7? 12 units. What's the square change from 2 to 0? 4. 12 divided by 4 giving us that value. Do we have real roots? Yes, we do. 0 is less than 7, so y equals 0 is bigger than negative 5. We have real roots. What are they? Those x values are measuring from 2 plus minus the square root of the change. The opposite of the change is 12, so negative 12 divided by, oh, no, it was, Jimmy, negative 5, excuse me. Been at this a while, so it's the opposite of k, so positive 5 over a term, which was 3. There we go. Took me a little while. Let's actually put that in graphing form just so that you can see why those numbers work and how they work. So we've got an a term of 3. I believe I erased it. I think I just did this one. X minus 2 squared minus 5, set it to 0. And let's actually plug, oh, we already did, so let's put our answers in here. Got to get a little more room. So our answers are 3 times 2 plus minus the square root of 5 over 3. Well, we can see the 2's cancel. When you square plus minus, you get a positive. When you square a square root, you get what's inside. The 3's cancel, and 5 minus 5 gets us 0. So those work. You can find them quickly and easily with practice. And that's what we're getting right now, some practice. All right, so you should be pausing the video at this stage and seeing if you can graph our third one, which is negative 4x squared plus 8x minus 9. Okay, pause the video. I'm just going to keep going. Cup shape down. I am on the increasing side. 0 gets me negative 9. Minus b, minus 8 divided by minus 8. Positive 1. Putting a 1 in gets me 8 cut in half. 4 minus 9 gets me negative 5. Notice I'm taking some shortcuts. Roots. Oh, they're imaginary because y equals 0 is above this number. So I got imaginary roots. It should show up with x equals h, which is 1, plus minus the square root of. The opposite of that is 5, but we're dividing by negative 4, the a term. And we can see that that is going to become 1 plus or minus the square root of 5 over 2 imaginary. Those are the numbers that are going to work. And so if we put this in graphing form, we would have negative 4 times x minus 1 squared minus 5. And then if you set that to 0, you took the time to do the inverse operations, you're going to move the 5, you're going to move the negative 4, you're going to do a plus minus square root of, which is 5 over 2 imaginary, and then you're going to bring over negative 1 and call it positive 1. And I don't have to write it, it's right there, but yes, I'm committed. Okay, and remember what happens when you square I squared equals negative 1. So what you're really imagining here, if we wanted to create a new axis, new imaginary axis, that's a height of 0. And what's really happening is I'm getting a sign change by squaring I, and those x values here would correspond to 5 units of change down here. Well, I guess that would have taken us to negative 10. Those x values are actually the same magnitude, just you're imagining a sign change, where instead of cup shape down, we're cup shape up. Just throwing a little concept your way. All right, so what else do we have here? We got another one, just like the other one. Okay, minus 2x squared plus 40x plus 5. All right, cup shape down. Same as the last one, I'm going up at 40 to 1 right there, 0, 5. And now I put negative 40 divided by 2 times this is negative 4, so positive 10. With positive 10 in here, I get 400. I cut it in half, I get 205. Okay, take more time with it, 10 squared, so that's minus 200 plus 400 plus 5. That's why I took the shortcut. You always get the opposite of this number or half of that one. Roots, do we have real roots? Yeah, down here, real roots. Okay, how do I get there? H, I gotta go down 205. But I'm dividing by a -2 plus minus square root. So they are real. And my H value was 10. And so I haven't done much with the quadratic formula in years, other than to find out if something's factorable or if the real roots are irrational or imaginary, whatever. All right, so b squared minus 4ac in this case would be positive. Nice positive number. It's not a nice number, so my roots are irrational. All right, but you can find that by doing this method as well. Okay, last one. Hope you got a little better. Again, I'm doing this quickly, but you got the ability to push pause. Go to last one is -3. Oh, I did 3 negatives. Minus 3x squared minus 6x, keeping the numbers simple. Do we want to be a little larger than that? Yeah, let's go 18. So let's go minus 18x plus 20. I just don't feel like doing the number 1 right now. So minus 18x plus 20. Cup shape down, this is good because I'm on that side now, at going down at 18 to 1. And I'm at 0, 20. So we're going to get real roots. There you go, Milo. I put the arrows on there just for you. 0, 20. And so now we got positive 18 over -6, -3. We drop -3, 54, cut in half, 27 plus 20 should get me 47. Let's check our A term. How do I get from 47 to 20? I go down 27. What's the square change from -3 to 0? 9. Okay, so we're good. That's just a quick verification. And so what are these intercepts? These intercepts that get me 0. H, I'm centering at -3. I'm moving to the right. I'm moving to the left. That's why the plus minus is there. And because they're real, I'm going to get -27 divided by A, which is -3. Oh, how nice. Positive 3. Okay, and I make you all memorize that in my class. So -3 plus or minus approximately 1.73 are my roots, approximations. All right, so there's a little practice. Did I miss anything that I wanted to just make you practice quickly and easily? I don't think so. So I'll post this one, and then tomorrow I'll do 2 more graphs, maybe exponential and log, maybe sinusoids, maybe square roots, absolute value, but we're going to get it done. We got another 3 weeks before the end of the term.